Okay, so today I am going to write a program in which we are going to take an input of a number and check whether it is a perfect number or not. Okay, so the objective is to check if the number is a perfect number or not. Okay, so now before proceeding ahead with the Python program, let us see what a perfect number is. So a perfect number. So the example of a perfect number is 6. So how do we know whether 6 is a perfect number or not? So before that, what do we do is we write down the factors of 6. So the factors of 6 are 1, 2, 3, 4 is not, 5 is not, 6. All right. Now, what do we do is we sum the factors. All right. We sum the factors, but we exclude the number itself. Excluding itself. Excluding itself. All right. Which means we are going to add 1 plus 2 plus 3. All right, and what this comes out to be is 6. So here we have excluded the number 6. All right, the factor 6 in the sum. Right, now the sum of the factors excluding the number itself is 6. Right, so what happens, my sum is equal to my number that I was testing for perfect number. All right, so if this is the case, this implies that 6 is a perfect number. Perfect number. All right, so now we know how do we get to identify whether a number is a perfect number or not. Therefore, what's going to be done in order to write the program for Python will be to let us try and identify whether we are able to convert this step-by-step process into the program or not. Okay, so over here, first of all, we'll have to find out the factors of the number. Now, before finding out the factors of the number, let us say that the sum into which we are going to keep the cumulative sum of the factors b is equal to 0 initially. All right, after that I'm going to take the input. So my n will be is equal to the input that I'm going to take. All right, now once the input has been taken, I will have to find out the factors of this number input. Now the factors will be that I will have to repeat until I reach the value n. All right, so for this I will run a loop. So for I in the range from 1 to n. Now remember friends that n is exclusive. Okay, n is exclusive in this for loop, and therefore we will be able to exclude this number 6 over here. All right, and if this, then what I will have to do is check if the number n modulus the value of I is equal to 0 or not. If this is the case, that means this I is the factor. Okay, so if n modulus I is equal to 0, that means that I is a factor of n, right? So if it is the factor of n, I will have to add it. So sum will be is equal to my sum plus the factor that I have identified. All right, now what has happened until now is that I've been able to find out the sum. Now once the sum has been found out, what I will have to do is I will have to check whether this sum is equal to this particular value n or not that has been taken as an input, right? So what I will do is I will check now if my sum is equal to the value n or not. Now once this is done, what will happen is that print perfect, else I will have to print that it is not a perfect number. Okay, not a perfect number. All right, so this is how the algorithm in simple can be written. Okay, so now let us try and dry run this particular algorithm. So initially let us see my sum. All right, what is the value of n that I am taking? All right, what's the value of I that it's going on to be, and then we'll see what my output is going to be. All right, so let's say the value of n is 6 and initially my sum is 0. So what is the first value of I? The first value of I is equal to 1. So when I divide 6 by 1, I find that the remainder is equal to 0. That means my sum is 0 plus 1. Then I go for the next iteration. So value of I is 2. So 6 modulus 2 is again 0. That means my sum is 1 plus the current value of I, which is now equal to 3. So now what will happen is that I will go for the next iteration. Value of I will be equal to 3. 6 modulus 3 is equal to 0. So that means my current sum will now be equal to 3 plus the current value of I, which is 3, is now 6. All right, so now what has happened, I'll go for the next iteration, which is equal to 4. So now 6 modulus 4 not equal to 0. It will go for the next iteration. Value of I will be equal to 5. So 6 modulus 5 again not equal to 0, and therefore what will happen is this time the iteration is going to stop because 5 is the last value where it has to stop when my range is from 1 to 6. All right, so my final output will be sum is equal to n will be checked. That means my value of sum is 6, my value of n is 6, and therefore my output should be is equal to perfect number. All right, so this is how we can create the trace table and we can check for whether the algorithm is running perfectly or not. So now let us go ahead and let us type this program in our IDLE and see if we are able to get the correct output or not. Okay, so let us keep the algorithm on the right hand side and let us type the program on the left hand side. Okay, so let's say my sum is equal to 0. All right, so n is equal to the typecast int input enter the number. All right, after this for I in range 1 comma n for any general value as per the input given. Next, if my n modulus I is equal to 0, then in this case I will have to find the cumulative sum will be equal to sum plus the current value of I, which has been identified as the factor, and therefore now I will have to check if the value of sum is equal to the value that was given as an input or not. If that is the case, then in that case I will print that it is a perfect number, else else print it is not a perfect number. Okay, so a bit of a typing issue error. All right, so now let us run this program. Okay, my program yeah, okay, so let's take the input as 6, enter, so it gives me as a perfect number. Now let's try it for another number, say for example 9, and it will tell me that it's not a perfect number. The factors of 9 are the factors of, let us try this out, factors of 9 are 1, 3 and 9. So when we exclude a 9, the sum is 4, so therefore 9 is not a perfect number. Okay, I hope you have understood how to get over such programs. All right, good luck, happy learning.